I will just go back to the program. So what I've done, I've just commented. You have seen in the previous class, I've just commented wherever I have used a semaphore, no, that I have commented. Okay, you can just see acquire I have commented, and I will comment the release part. I'll comment the release part over here. Now just see the kind of output, the variation that you will get. Okay, so semaphore will manage explicitly that synchronization. Please remember this. When we had taken threads, no, we had written that synchronization block or synchronized keyword. Then we had used a synchronized class. We may have used a synchronized method. Okay, so all those things are taken care by semaphore. I need not bother about it. Even if I link that semaphore, okay, even if I link that semaphore and call acquire and release, it will do automatically the things. Okay, this is how you have to understand this. Now I will save this. What I have removed, all those semaphore related stuffs I have removed. Just have a look at the kind of the output that you are getting. Okay, just have a look at this. A has asked for a permit. A has got the permit, but who is starting? B is starting. B also has got the permission. And look at the counter variable, the count, which is a shared variable. Okay, A, for A it makes it 1, B it makes it again 0, then B makes it -1. It is inconsistency. Okay, data inconsistency. I have not written yet, but people have started editing on it. 2 persons at a time are editing on it. Okay, so it becomes definitely inconsistent data. Okay, suppose a reader and writer is sitting. 2 writers are there, 1 reader is there. You just have a situation like this. 2 writers are there, 1 reader is there. Both the writers are writing at a time. Think like this. And in between, the reader comes and reads something. Definitely, the data will be inconsistent. Until and unless the writers complete their task, reader cannot be permitted. This is the beautiful example that is available. One more is producer-consumer example. Okay, here people talk about acquiring the lock, complete the production, only then allow the consumer to consume the things. This is the best example of semaphore. Reader writer problem. Until and unless writer completes total of writing, reader is not allowed. These are the best examples of semaphore usage. Any doubt at this point? Please let me know. Any doubt at this point? Let me know, guys. Any doubt at this point? I will glance through the program again. Okay. Any doubt at this point? No doubts?
No, ma'am, no doubt.
Okay. So when I glance through the program, see, guys, threading part, I cannot repeat again. You have to understand it. It is a simple thread class created. Nothing else other than that. Nothing else other than that. Is there any difference between this and the previous things that we have written? Only thing that is being done here is you are giving the name of the semaphore. Okay, whatever name n you are supplying, double quotes A, double quotes B, that I am supplying here. What is this semaphore S speaking about? The semaphore object that I have created with a count of 1. That 1 indicates how many threads at a time can work. Okay, so that you are supplying, nothing else other than that. Using this, you are calling on the start. Once you call start, it will go to the run method equivalent to that. In the run method, I have to acquire the permission first. Acquire the permission. Until and unless you acquire the semaphore will there will not be actual clear separation of the working. Okay, so this acquire talks about thread 1, telling that thread 1, I want to utilize the permission to update the counter. Okay, so once you write this, you are telling that you are acquiring the grant on the count variable which you are incrementing. Then once you have done, this is the shared resource. Count is a shared resource. You are doing the updation in that. Once you are done, then what you will do? After you have done that, you are telling that I'm done with my work. I'm releasing the count. I'm releasing the semaphore. The lock is released to you. Then the second thread will take over. But second thread cannot take over automatically. What it does? Definitely it takes automatically, but there has to be lock acquiring, because there may be a case that when second thread is working, third thread may come. There has to be locking mechanism. You have to close the door before you go for any important work inside your room. Until and unless you lock the room, somebody else can interfere. Obviously, this is similar to that. You have to acquire the lock on the shared resource. Only then you can work on it. This is the overall working of semaphores. I hope there are no doubts in this. I hope there are no doubts in this. Okay, on this basis, let me show you one very important application of semaphores, which is called as producer consumer. In actually threads chapter, you should do this program, but since it is not been done in your basic Java, I have to go through this example. Okay, this is the most relevant example for semaphores. I will just go back. Just have a look at this. I will be creating two semaphores here. Okay, I'll be creating two semaphores here. For the first one, semaphore consumer, I will pass the value as 0. Why this I have to pass it as 0? Because when the consumer starts working, no other person will come. Okay, I will make sure that this semaphore consumer initially is not available. It will come into picture only after the producer has completed. Only after the producer has completed. See guys, what you can do is you can give both 1 and 1 also. Nothing wrong in it. Nothing wrong in it. But writing 0 indicating initially this semaphore is unavailable. Okay. You can write 1 and 1. Not an issue at all. Not an issue at all. Okay. Now, then what is that I'm doing? Inside this Q class, there is get method, put method. Get and put are used for reading and writing. Get is for reading, put is for writing. Okay. Whenever get method is there, I have to release a producer, because producer does what? Putting. Who does getting? Consumer. When I write get method, uh, or else let me go ahead with main first, then I will explain this. Okay, in the main, how this will be done? There is an object created for Q class. Q class has put method as well as get method. Okay, then there are two thread classes, one thread for the producer and another thread for the consumer. Okay, producer, what it does? It just produces the numbers. It just produces the numbers. Consumer, what it does? It consumes it and releases the lock. Once I have reached, once I have reached the dead end of producing, I will stop the producer. Once I have reached the dead end of consumption, the consumer is stopped. Okay. So simply the producer as well as consumer are called here. Nothing else other than that. Okay. So when I go back to the Q class, there are two methods in it. The get method, getting is nothing but reading. Reader writer. Okay. Getting is nothing but reading. Take out the number. When I'm getting something, I have to make sure that producer is not producing. Putting is not happening. So how I can do that? I can do that by explicitly calling producer semaphore has to be released. The first example was talking about single semaphore acting on two threads. Okay, single semaphore acting on two threads. Here there are two semaphores which are acting independently. So now what I will do, once my current consumer semaphore is active, the producer semaphore has to be released, because producer cannot continue producing because I am trying to consume now. When I am reading, writer should not write. Okay. So first task that I'm doing, release the producer. If you want to implement this using a single semaphore also, it is okay. Then you have to rewrite the same thing. This whole thing can be taken as single semaphore reader writer problem, producer consumer problem. This is where two semaphores are there. Production, one semaphore, acquiring another semaphore. So now, first task that I'm doing is release the producer. Then what I will do, consumer has to acquire the lock. Okay, again this comes in try catch block. Then inside the put method talks about consumer. I'm writing something, so the reader has to sit quiet. So in this, I will call the release on consumer semaphore. Okay, then I will acquire the lock on producer. So since I cannot use acquire independently, I have to put it in try catch block. Then what else? I'm just putting the number that I have read. Sorry, I'm just putting or updating the number. Here I'm getting the number that is being produced by the producer. Now, when I go ahead, how this producer and consumer will work? Producer will call the put, consumer will call the get method. So accordingly, this producer, again it calls the start method, that in turn calls the run method. Inside this run method, I am trying to put I. What is this put I? Put, when I go back, put talks about, see, put talks about taking a number. That number I'm printing. That number I'm printing. But actually, if you use buffered writer, I will use and write that number to the buffer. Okay, that is much more complicated than this. Now, inside the consumer, there is a call for get method. How many times? 10 times. Why 10 times? Because 10 times the producer has produced. Simplest method of implementing producer consumer using semaphores. Okay. Then create the object of producer, create the object of consumer. Nothing else other than this. So let me run this program. Just have a look at this. The kind of output that you'll get. As soon as a producer produces something, the consumer will get that. So this is producer, this is consumer, producer, consumer, producer, consumer. See, this is working two threads parallelly in such a way that at a time, round robin algorithm it is, implementation of round robin algorithm. How about this semaphore example? At once the first thread completes, the second thread then begins. Okay, this is how the first and the second are different. Any doubt here? Any doubt here? Any doubt here?
Ma'am, if you make the
Yes, Irana.
producer semaphore one, ma'am, will there be any error? Like
Oh,
interrupt will be raised.
1 minute. 1 minute. Let me go to the top. Sorry. Producer consumer example, no? You're talking about? Okay.
Yes, ma'am.
Yeah. Let me make this one. There is no error.
Okay, ma'am.
See, I told you initially only. You can tell that there are zero number of people other than me. There are zero number of people who are working on it. See, it is just trying to tell, initially initialized to zero, it is just trying to tell consumer initially is unavailable. Only after producer tells I'm releasing my lock, consumer can start. Only with that intention, zero was written. But if you write, even if you write one, doesn't matter. At a time, one thread is working on the shared resource. I have made it one only. Okay?
Okay, ma'am. Yes, ma'am.
Yeah. Uh, now, the last part, okay, countdown latch I'll go. Then we will end the session. Okay? Just 10 more minutes. We'll go to countdown latch. What is this countdown latch? I think I have spoken about it previously when I started talking about this synchronizers. Okay. There is a number associated with the countdown latch which talks about on the shared resources. On the shared resource, how many events will occur. Until that time, that particular set of threads or a single thread will hold the lock. A single thread can hold the lock until those many number of events complete. Okay. Soon after the number of events are over, the lock or the latch gets released. This is what is countdown latch. Any particular log is associated with count of the events that need to be completed before releasing the lock. This is how a semaphore is different from countdown latch. Semaphore talks about acquire the lock and release the lock. It doesn't bother about anything else. But countdown latch talks about you specify how many number of statements, till how many number of statements I have to continue the lock. Okay, the number of events that define the countdown latch. This is how semaphore differs from countdown latch. So there are two ways in which I can go ahead. The first constructor talks about countdown latch, which talks about the number of events, int num, as a parameter. That talks about how many events need to occur before I end my lock. Okay, there is something called as await, which tells me how long I have to wait. See, there are two ways in which I can call this await. When I have called countdown latch with the number of events, await doesn't have any kind of parameter associated, because soon after those many number of events are over, the await will change over to the release. Okay, but when countdown latch is not associated with number of events, it will explicitly tell that you have to wait until this time. You have to acquire the lock until this time. The time unit is decided by the enumerator TU. Time unit is already inbuilt. Okay. So what is this waiting time? Is it in number of seconds? Is it in number of nanoseconds? That is decided by the time unit, the second parameter. So when I tell 5, it talks about 5 seconds or 5 nanoseconds. That is decided by the second parameter. Okay. Yeah. Yes. Guys,
Yes, ma'am.
speak up.
Yes, ma'am.
Yeah. Okay. So this countdown latch talks about number of events parallelly happening once the lock is acquired. That lock gets released once those events are ended. So keep this in mind. Accordingly, the countdown latch will work. Okay. Decrements the count as soon as one such event occurs. One such event occurs. Okay. Now, I'll just show you one program on the countdown latch. So this is the last thing that I'm discussing. So in the CDL demo, you can just see there is a call for await. You can just see there. Just 1 minute. I'll just move this a bit. You can just see there is a call for countdown latch constructor on the value 5. What is this 5 indicating? 5 indicates 5 number of events have to take place. Until and unless this 5 becomes 0, the lock will be held by that particular thread. Okay. Now, I have called this await without any parameter. The reason for that, because 5 has been already passed by the constructor, through the constructor. Now, when I call await without any parameter, it waits until the 5 events are over. That is the meaning of this. Okay. So I have taken one thread that uses the object of countdown latch class that is being created up, and in the run I have just imagined that decrementing is nothing but, or incrementing is nothing but the event. Okay, so on the latch that I have called over here, on the latch that I have called, I'll call the function countdown. Okay, how many times? 5 times. So this goes very simple. What is this countdown? When I go back, the countdown I have called on the value 5. The value 5. So obviously countdown will happen from 5, 4, 3, 2, 1. Okay, the initial value that is supplied in the constructor, that will be taken in the countdown. So whenever that latch is associated, how this latch is associated, just have a look at this. It is associated to C. What is this C? C is supplied by the constructor over here. Okay, C is supplied by the constructor over here. The CDL is passed. What is the CDL? CDL is a object of countdown latch. Okay, and that is associated with the initial value 5. What this means, 5 events have to take place. So 5 times it sits back. It awaits 5 times. Then beyond that, once the countdown has, have you decremented anywhere the counter? You are not decremented. There is explicit countdown happening. Decrement of countdown is happening explicitly. Okay, this is where the countdown latch works. This is how it is different from semaphore. I hope there are no doubts in this. See, all these things will be shared to you in the Google Classroom. Please go through them. And if you have any kind of doubts, you can contact me.